Hello, today's lesson is on finding the greatest common factor. The essential question is, how can you find the greatest common factor of two numbers? And we'll start off with a definition. The greatest common factor is the largest whole number that is a factor of each of two or more numbers. So notice up there the essential question just had to do with two numbers, but you can find the greatest common factor of more than two numbers. In other words, the greatest common factor is the biggest factor that is shared by two numbers. So this is in the textbook, page 32. And so there's more than one way to find a greatest common factor. And the first way that we're going to go over is to use a list of factors. And so you made lists of factors last week, and we used T-charts. And so the T-charts that we used look like this, right? If I was finding factor pairs of 20 and factor pairs of 40. And so you're welcome to use T-charts to find your list of factors, or you can use a multiplication chart. I'm going to go ahead and just list the factors. Well, let me just do this in a T-chart just to make sure that you remember how to find factors in factor pairs in a T-chart. So the idea is I was trying to figure out what two numbers multiply to get 24, or I'm taking 24 and dividing by 1 to get 24. 24 divided by 2 is 12, 24 divided by 3 is 8, and 24 divided by 4 is 6. Those are all my factors of 24. So now I can list them in order from least to greatest. 6, 8, 12, 24. And then I could do the same thing with 40, 1 times 40, 2 times 20. If I start to write a 3, then I go, ooh, wait a minute, 40 isn't divisible by 3, I can just cross it off. And then 4 is divisible, 4 times 10, 5 times 8, let's see, 6 and 7, nope, those are all of the factor pairs of 40. And so I make a list, 1, 2, 4, 5, 8, 10, 20, 40. And now I circle all the common factors, right? So I'm looking for common factors. Common are things that are the same in both lists. So those are all my factors. And then what I want to do is I want to find the greatest. So I could just make a list of common factors. I'm not recommending you do this every time because it gets a little tedious. Those are my common factors. And then notice that the greatest common factor is the biggest number. So the greatest common factor is 8. All right, so this is the OYO. You are trying these on your own. Go ahead and if you missed class, pause the video and try these two problems on your own, and then restart the video and see how you did. So I'm going to show you again, if you want to do factor pairs because it's easier for you, you're welcome to do that. I'm just going to go ahead and list the factors of 8, 1, 2, 4, 8, 36 is 1, 2, 3, 4, 6, 9, 12, 18, and 36. And then I'm circling the common factors. I see 4, and it looks like 4 is the greatest common factor. There we go. And now for 18 and 72, again, I'm just going to make my list. 1, 2, 3, 6, 9, 18. 72 is a little harder for me, so I might recommend that you make a list of factors using the T-chart or the factor pairs. Let's see, 72, divided by 2 would be 36. And I know 3 goes into 72 because 7 plus 2 is 9. So then I could use my multiplication chart and see that it's 3 times 24. And then 4 is also a factor, 4 times 18. 5, it doesn't go into 72 evenly because it doesn't end in 5. 6 times 12, and then not 7, it would be 8 times 9. And then I can go through and make my list in order from biggest to smallest. You can see that making a list of factors, with a number like 72, there's a lot of factors, and this gets a little tiring, so I'm going to show you another method. All right, so the 1 they have in common, they have a 2 in common, they have 3, they both have 6, they both have 9, and they both have 18. So you can see that every single factor in 18 is also in 72, but then there's some more from 72. All right, so out of that whole list of factors, and I've circled all the common factors, the greatest common factor is 18. Okay, so making lists, that's a lot of work. So I'm going to show you another method that you can use. This method is the prime factoring ladders that we did last week. And so here's the idea, right? You have to have your list of prime numbers before you start your prime number your factor ladder. And notice I have a factor ladder for both 12 and 56. So I'm going to start out with 12. It's an even number. Divide by 2, and I get 6. Divide by 2 again, I get 3. Now I can only divide by 3, and I'm left with 1. Now I'm also going to factor 56 with prime by dividing by primes. Divide by 2, I get 28. Divide by 2, 14. Divide by 2, 7. Divide by 7, I get 1. Remember, every time I'm doing prime factorization, these are all the prime factors of that number, and you multiply those together. But this time I'm not going to get fancy and use exponents, because it's going to make more sense to find common factors if I don't have it written in the exponential form. So 56 is 2 times 2 times 2 times 7. I want to make sure I wrote down all the factors correctly. 2, 2, and 3, 2, 2, 2, and 7. There they are. And now, just like when I listed factors, when I made a list like we did on the previous page, the idea is I'm circling the common factors. They both have a 2. They both have a second 2. Now 56 has a third 2, but 12 does not. So I cannot circle this one. It is not a factor they have in common because it has to be in both lists. Now I can see that 2 is a common factor and a second 2 is a common factor. So really what I'm saying is 2 squared is the common factor, which you know is 4. So the idea is I multiply the common factors together to get 4 as my greatest common factor. And so notice I've got this little, you can't see it because I need to grab this bar and move my screen over a little bit so that you can view that. So over here, I've got this note that says, why make 2 factor ladders when you can just make 1? Oh, how cool. What? I can make just 1 factor ladder for both numbers. Whoa, this is really cool. So instead of prime factoring 12, prime factoring 56, and having 2 separate ladders, I'm just going to do it all in one. And it's really slick. I think you'll like it. So again, I have the numbers written inside the ladder, and I'm going back to my list of primes. But this time, I have to make sure whatever prime number I divide, it has to be divisible in both of the numbers. So they're both even. I divide by 2, and I get 6. When I divide 56 by 2, I get 28. You already know that because we did that up here. And now they're both even, and I divide by 2 again. 6 divided by 2 is 3. 28 divided by 2 is 14. Okay, now here's the deal. I'm going to stop here. I'm making a little note to myself. Because up above, we kept dividing until we got 1, because I was only prime factoring 1 number at a time. But here, I'm dividing common factors of 2 numbers. And so you're not going to get down to a 1. Sometimes this very last part of the ladder, you have both prime numbers, but you don't have to, it doesn't have to end in both prime numbers. 3 is prime, 14 is not. The important part is they have no common factors, right? If, oops, move that back down. If, let's do that. If they had common factors, then you would have had to keep dividing, but they don't. So I'm saying stop because they have no common factors. Okay, this is the cool part. This over here, that's just what we figured out from up above doing the single ladder for each number. And so all of the numbers on the left-hand side are going to multiply together to give me the greatest common factor. 2 is a common factor. The other 2 is a common factor. 2 times 2 is 4. So my greatest common factor is 4. If there was only one number here, then it would just be the one number. If there's 3 or 4 numbers, you would multiply all those together. Leave these numbers down here where it says stop. Those are not part of the common factors. We did not divide 3 or 14 out of any of these numbers. Okay, so we're now on to OYO. You guys are doing this on your own. Why don't you pause it and then come back in and check your work and see how you did. So I'm going to put 20 and 45 in the ladder, and then I'm going to look at my list of prime numbers and start dividing out common prime numbers. They're both divisible by 5 because it ends in 0 or 5. So I put a 5 on the outside. 20 divided by 5 is 4. 45 divided by 5 is 9. And now I'm going to write stop. I can't divide anymore. 4 and 9 don't have any common factors up here. So guess what? I'm done. The greatest common factor is 5. There's only one number in the ladder. All right, 32 and 90. They are both even numbers. Divide by 2. I get 16 and I get 45. And whoa, this is divisible by 5 and 3. Oh, but that's not divisible by 5 or 3. I guess on this one, I'm also going to have to say stop. I can't divide out any more prime factors. So guess what? Greatest common factor is 2. And now for the last example, let me pull this over a little bit. Okay. I write 45 and 75 in the ladder. Come on, pen. There's my 45. There's my 75. I look for common factors to divide out. It looks like they're divisible by 3 and 5. And the order doesn't matter that you divide by. So let's go ahead and divide by 5 because that one's just seeming like it'll be easier for me. 45 divided by 5 is 9. 75 divided by 5. Well, if I don't have a multiplication chart, I'm just going to do a little math up here. 5, 25. Okay, it looks like it goes in 15 times. And now I can see these are both divisible by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. Okay, I have a 3. I have a 5. Those are both prime numbers. They have no more common factors. The 3 is common, the 5 is common, and I must multiply them together to get 15 as the greatest common factor. Okay, hopefully that's starting to make sense to you. This is the second way that you can use to find greatest common factors. Hopefully you'll figure out if you like the ladder method or the list method better. Bye-bye.